Yes, we acknowledge how infinitesimal the size of the atom is, but with certain mathematical assumptions, we can estimate the size of an atom. So how do we do that? We do that by combining the following. The atomic mass, the atomic mass and the density of the atom. You know that mass divided by volume gives you the density. So from these two, we can get the volume occupied by 1 mole of the atom. Because this atomic mass is the same as molar mass, molecular mass. But since the atom is not a molecule yet, we can go with the term atomic mass. So from the molar mass and the density, we calculate the molar volume. And this molar volume is the volume occupied by 1 mole. Now, from this, we can now estimate the volume occupied by 1 atom. That's atomic volume. From atomic volume, we can calculate the radius of the atom. Because volume has a mathematical formula. So let's go. Our case study is gold atom. So, from periodic table, the molar mass, or let's say the atomic mass of gold, the atomic mass of gold is 197 grams per mole. Density of gold is 19,320 kilograms per meter cube. That's the density of gold atom. Now look at these two. The density is in kilogram per meter cube, while the molar mass is in gram per mole. So this gram and kilogram cannot work. We convert the gram to kilogram. You know that 1,000 grams is equivalent to 1 kilogram. Therefore, 197 grams of gold will be equivalent to 1 kilogram divided by 1,000 grams times 197. Gram, we cancel gram. And what do we have? 1, 2, 3. We have 0.197 kilograms per mole. So sending to standard form proper, we have 1.97 times 10 raised to power minus 1 kilogram per mole. But we are going to recall that density is equal to mass over volume. Now we have found mass, we have found density. Let's find volume. Volume is going to be mass over density. So we calculate the volume, the molar volume. The molar volume is mass, molar mass over density. And the molar mass was gotten to be 1.97 times 10 raised to power minus 1 kilogram per mole, divided by the density, which was found to be 19,320 kilogram per meter cube. So it's better we convert this to standard form too. 1, 2, 3, 4. So 1.9320 times 10 raised to power 4 kilogram per meter cube. So we continue. 1.97 divided by 1.9320 times, you take 110 there, minus 1 minus, because of division, minus 4. And we have 1.97 divided by 1.9320 times 10 raised to power minus 5. So this will give us 1.01967 approximately times 10 raised to power minus 5. This is full now. Okay. So what is the unit? Kilogram here, we cancel kilogram up. So meter cube goes up to become meter cube goes up to become meter cube per mole. Meter cube per mole. So this is the molar volume. Meanwhile, this is the volume that occupies 1 mole of gold. And 1 mole of gold contains the Avogadro number of atoms. Recall the Avogadro's number, 6.02 times 10 raised to power 23. So this is the exact number of atoms in 1 mole. So we say per mole. per mole is the number of atoms that occupies this particular molar volume, 1.01967 times 10 raised to the power minus 5 cubic meter per mole. So this is the number of atoms that occupies this volume. If that is so, let us find the volume occupied by one atom. One atom per mole would occupy 1.01967 times 10 raised to the power minus 5 cubic meter per mole, divided by Avogadro's number, 6.02 times 10 raised to the power 23 per mole. Per mole, we cancel per mole. So we have 1.01967 divided by 6.02 times, you take 110 raised to the power minus 5, division becomes minus 23. So what do we have? 0.1694 approximately times 10 raised to the power minus 5 minus 23 is minus 28. To have a proper standard form, shift point to the front of 1, we have 1.694 times 10 raised to the power minus 28. Because you shifted to the right, you remove 1. So we have 1.694 times 10 raised to the power minus 29 cubic meter. So this is the volume occupied by just one atom. So since this is the volume occupied by just one atom, assuming that the atom is a perfect square, it now leads us to the volume of square in mathematics. Perfect sphere. So volume of sphere volume is 4 pi r cubed over 3. That is the volume of sphere. Now, this volume of sphere, 4 pi r cubed over 3, is, we are seeing the sphere as the atom, and that gives us this volume, 1.694 times 10 raised to the power minus 29 cubic meter. So, over 1. When we clear the fraction, 4 pi r cubed times 1, the same thing, will give us 3 times 1.694 times 10 raised to the power minus 23 cubic meter. So, we make r cubed the subject. R cubed will give us 3 times 1.694 times 10 raised to the power minus 23 cubic meter divided by 4 pi. And 4 pi is 4 times 22 over 7. So, that is r cubed. Let's now manipulate this. 3 times this will give us 5.082 divided by 4 times 22. That is 88 over 7 times 10 raised to the power minus 23 cubic meter. So we are going to have 5.082 divided by 88 divided by 7 is 12.5714 times 10 raised to the power minus 23 cubic meter. 5.082 divided by 12.5714, 0.4043 times 10 raised to the power minus 23 cubic meter. Now, remember, this is cubic radius. Therefore, only one radius will give us cube root of 0.4043 times 10 raised to the power minus 23 cubic meter. Remember, it's cube root. Oh, wait a minute. I think this 23 shouldn't be. Look at this volume, atomic volume. It's not supposed to be minus 23 at all. Let's go back. Look at it, minus 29. Sorry, so let's continue. Let's trace that. Minus 29, minus 29, minus 29, minus 29, minus 29, minus 29, minus 29. Okay, let's continue. So, after estimating this, the radius of gold atom is now 1.593. It's 1.593 times 10 raised to power minus 10 meter. This is the radius of gold atom. We can finally convert to picometer. We know that 1 meter is equals 10 raised to power minus 12 picometers or picometer. Therefore, 1.593 times 10 raised to power minus 10 meter will give us 10 raised to power minus 12 picometers over 1 meter times 1.593 times 10 raised to power minus 10 meters. And finally, we will get 159 picometers. So gold atom, the radius of gold atom is 1.593 times 10 raised to power minus 10 meter, or 159.3 picometer. This is the size of gold atom by radius.